So, YUI3 autocomplete. It's been a while in coming. Obviously, we're at YUI 3.3 now. Autocomplete first showed up in YUI 2. So why has it taken so long to get it in YUI 3? So I'd like to start by giving you a brief history of autocomplete in YUI, just to tell you where we've come from and some of the things that we're building on in YUI 3 autocomplete. So autocomplete first appeared in the very first public release of YUI. So YUI went out the door, it went out the door with an autocomplete widget. And not only was it one of the first YUI widgets, it was one of the first autocomplete widgets, one of the first open source JavaScript autocomplete widgets on the web. So kind of pioneered a lot of the APIs, the interaction patterns, some of the things that you take for granted now. And since that time, it has become one of the most popular YUI widgets. So you'll see this all over the web, not just at Yahoo, but everywhere. And sometimes you won't even recognize it. You won't just see a normal list dropdown. You'll see various patterns like what Delicious does, where they're doing a more assist-like autocomplete pattern, something that doesn't really fit into that typical pattern that you expect. So because there are so many of these patterns, this is the slide that says what I just said. In the YUI 2 world, this left us at a bit of a disadvantage. YUI 2 had a more monolithic module architecture. So you had one module that was responsible for taking care of all of the stuff that you were going to do with the widget. And then any options that widget wanted to expose, they all had to be handled by this one module. So this ends up not being super great when you have something like autocomplete that has such a wide range of different patterns. There's not just a list-based autocomplete. There's also doing things like filtering of items on a page. There's things like instant search, more and more patterns that we're starting to see built on top of this autocomplete metaphor. So in the YUI 2 world, if you wanted to do this, you could certainly build this on top of YUI 2 autocomplete, and it was really powerful, but then you had sort of that dead code for the list widget that you might not be using. So that was unfortunate. But luckily, YUI 3 lets us take a more granular approach, and the way YUI 3 is structured, we can break all those little pieces of the interaction into individual modules that are responsible for just their own little set of functionality. And we don't have to force you to load this list widget for whatever else you may be building that just happens to have an autocomplete metaphor involved. So I'd like to introduce you to YUI 3 autocomplete. That's what it looks like. Nothing super exciting. This is something we've all seen. But there's a lot of stuff going on under the hood. And there's a really solid modular foundation under this that's making this simple list widget possible and that you can use to implement things far beyond just this list widget. So as part of the new modular API, we've tried to make things more flexible. We've tried to give you more extension points so that you can hook into these things without having to go through a list, without having to go through a widget. You can basically accomplish anything that you want to accomplish, also without having to rewrite these core patterns that autocomplete will provide for you. So this is what the module structure looks like in autocomplete. And I've also included a module that's not technically part of autocomplete, the event value change module. I've included here because it's really foundational. It's something that autocomplete builds on top of. So it does have a lot of bearing on this module structure. So starting with event value change, what this does is this is a synthetic event. And all it does is it looks at an input field or a text area, and it waits to see when the value changes as a result of user input. And then it'll fire an event whenever that happens. So then you have the autocomplete base module, and this is the core logic layer of autocomplete. So this provides all of the logic that goes on behind the scenes when the user types something, when you make a request, when you handle a response, but it doesn't imply any UI on top of that. So this just handles the under-the-hood stuff. You've got a couple of optional modules that build on top of autocomplete base, so you can mix in a set of prepackaged filters and highlighters for results. So if you want to do filtering locally, if you want to do highlighting locally, we've got these nice modules that provide a nice prepackaged set of those so that you don't have to write them all yourself. And these are optional. You don't have to use these. And then finally, you have the autocomplete list widget, which is the thing that everybody thinks of when you think about a basic autocomplete implementation. This is the pretty widget that provides keyboard interaction. It provides the highlight states when you mouse over things, all that fun stuff. And again, that's optional. You can layer this on top, or you can build something else of your own on top of it. So when you break down the way the modules are structured, the way they're built in terms of just the size of the different modules that make up autocomplete, and you compare it to YUI2, this graph is misleading. So if you look at this, you look at it and you say, oh my god, YUI2 is like a kilobyte bigger. YUI3 is going to be awesome. And that's cool. Actually, the graph is misleading because YUI2 autocomplete has a slightly smaller set of dependencies, but it's also less flexible. So in return for allowing YUI3 autocomplete to have a little bit wider dependency base, you get this more modular structure where you can say, I only want autocomplete base, or I want base plus list, or I want base plus filters, but not the highlighters or the list. You have that flexibility to choose which of these you're going to load, and so you can customize your page weight hit that you're going to take for using autocomplete. So in terms of functionality, it would be super awesome if we could go out the door and say everything that you could do in YUI2 autocomplete, you can do in YUI3 autocomplete. We've tried to do that. We've gotten about 90% there, and I had a team of scientists actually help me come up with this number. So there's a lot of math behind it. That's a bald-faced lie. I just made it up. In terms of most of the features that you're used to from YUI2 autocomplete, in terms of configuration attributes, things like that, you're probably going to find most of the things you would want to use. There are a few things that YUI2 autocomplete does that are not being done yet, and those will come absolutely in future releases as we continue building out YUI3 autocomplete. But the really important stuff is here. This is just a list of some of the configuration attributes that you've got available to you. And today, I'm not going to go through all of these, so you can hit the API docs if you want to see details on all of them. Today, I'm mostly going to be focusing on these ones, because this kind of gives you a deep dive into what autocomplete is doing for you. So the first thing that you're going to want to do when you're working with autocomplete is find some results. So autocomplete tries to make it really, really easy for you to provide results in whatever format is most convenient for you. So if you've got a local array, if you've got an object, or if you've got a full-fledged YUI3 data source sitting around, all of those will work as result sources. You just plug those into autocomplete. In addition to that, you can use a plain JSONP URL as a string, or you can use a YQL query. So you just give autocomplete a YQL query, and it knows exactly what to do with that query, how to find results, how to parse them out of the response. Super awesome, I think. But you tell me. So you've also got the prepackaged set of filters and highlighters that I mentioned. So you can be lazy and use those, which hopefully should meet most of your needs, or you can write your own. That's really easy to do. The built-in filters and highlighters are actually pretty advanced. So they support word breaking and accent folding. And there are some caveats here that I'll talk about a little bit later. But in a case where you aren't able to do this on the server, say you're pulling results from somebody else's server, and you want to do some word breaking that goes beyond just a simple regex word break, or if you want to do some accent folding for comparisons, we've got an implementation that can help you out there. In terms of formatting the results, you don't always want just a list of text in your autocomplete dropdown or in whatever other form that you're displaying these results. So we make it really easy for you to provide a custom result formatter. So you can say, when results come back, run through the list of results, apply some formatting, turn them into some HTML, I'll throw some CSS on top of it. So it's really easy to do that. And most importantly, we've made autocomplete fully accessible out of the box. So it's fully marked up with ARIA. It's an actual ARIA autocomplete widget. You don't have to do any extra work to get this. You throw autocomplete on a page, it's going to be accessible, unless you actually go out of your way to break it. So don't do that. And it's mobile ready out of the box. You don't need to have a different autocomplete implementation for desktop and for mobile. You throw this thing up on a site that you've written for a desktop browser. As long as you've done your design work and as long as your design scales, the autocomplete widget is also going to work on mobile. And if you look really closely at this picture, you may notice this phone doesn't have a keyboard. So AutoComplete has a really rich set of keyboard interactions, but there's no point loading that stuff. Oops. Yeah, there's no point loading that stuff when there's no keyboard. So we use YUI3's conditional loading to say, if we're a mobile device that doesn't have a keyboard like an iPhone or some Android phones, don't bother pulling in this chunk of keyboard code. Just leave it on the server. No point making the client load that. So that's super awesome. And this is the code cat. He wants to see some code. So I'll show you some code. This is what it looks like to use AutoComplete. That's a complete implementation. This will work out of the box. So all you have to do is pull in the AutoComplete module in your YUI use statement, grab a reference to an input field, plug in the AutoComplete plugin. So you say, take this input field, add this plugin to it, which augments it with some functionality. And then you give AutoComplete a source to pull its results from. In this case, I'm just using a YQL query. And AutoComplete will take care, behind the scenes, if you haven't already loaded the YQL module, AutoComplete will pull that in automatically from the CDN. It'll, as the user types, it'll make requests to YQL. It'll figure out the responses, do all that for you. So this will work out of the box. So that's the basic usage. You can also use it in a widget style if you're more used to instantiating a widget and then rendering it later or instantly, whichever you're more comfortable with. You can do that too. There's no real difference. The only difference here is instead of a plugin, I'm just instantiating a widget, and then I can hang on to that later. And then passing in my input node and optionally delaying the render step. So that was a YQL result source. I can also provide a JSONP URL with a couple of placeholders. So in this case, instead of a YQL query, I've got an actual URL. It's got this query placeholder and a callback placeholder in the URL. AutoComplete will fill those in on each query with the current query and a callback function that's going to handle the response. And then it'll go out and make JSONP requests. And as long as your results come back in the form of an array, you don't have to do any extra work. This is going to work for you. So there's a lot of stuff you can do with that. If you've got a local array just sitting around, we're not going to make you stick this array in a data source if that's all you want to use. Just give the array to AutoComplete. It'll take care of all the complexities behind the scenes of setting up that array as a source for lookups. So in this case, as the user types, I'm just going to be returning this array as results, and then any filters and highlighters that I've configured are just going to work off of this array. You can also use an object as a result source. So instead of an array, now I've got an object that's got keys and values. And in this case, as the user types something like pies, AutoComplete is going to find the pies key on this object, and it's going to return that array. If the user starts typing cookies, AutoComplete is going to find that property on this object and return that array. So if you've got a lot of local data sitting around, but it's nothing too complex, this makes it really easy to use without needing to create a full-fledged data source. So if you do want to create a data source, let's say you've already got a data source on the page, you're working with a data table, or you're doing some other heavy lifting, you can share that with AutoComplete. So this is a great way to share the source of your data between multiple widgets, or if you just want to do some more heavy lifting, if you want to apply a data schema or some data types to your data source, you can do that. And the only difference here is I've instantiated a data source. I've also specified a request template which tells AutoComplete for each query, take whatever URL is set in the data source, append this template string to it to create the final URL. And this template will contain a placeholder for the query that's going to get replaced. And the request template can also be a function if you need to do some additional logic. So you've got a lot of flexibility there. So I'm going to take a deep dive and talk about some of the really cool things you can do as you start writing your own result filters, writing your own formatters, and how AutoComplete will help you do some of that stuff. So the first thing that you want to do if you're making remote requests is you're going to get back a response, and you're going to need to locate some results in that response. And just tangentially, I'd like to point out that the Empire uses Google almost exclusively. So read into that what you will. So back to a JSONP example. I've got a JSONP source. Let's say my JSONP source returns this array. So that's super awesome. That array is going to work out of the box. Nothing extra that I have to do there. But let's say that my source this is probably more likely going to be the case in a lot of situations. Let's say it returns an object, and this object has an array of results buried in there somewhere, but AutoComplete doesn't know anything about this object. It doesn't know how to dig in and find these results. So you're going to have to tell it where to find that array. So that's a bit of a problem. You have to do some extra work, but not very much. All you have to do is provide a result list locator. And this is just a string that contains an object path, and it says, look for the source property, or excuse me, look for the search property, find the results property of that, and that's your array of results. So really, really easy to tell AutoComplete how to dig into a formatted object structure. So that's awesome. You can also specify a list locator as a function. So let's say you've got responses coming back that aren't always in the same format, or if there's some extra logic that you have to do to, whatever you need to do for a response that's coming back, just provide a function that returns an array, and you can take care of all of that yourself. So here's a real-world example using the Twitter Search API, which is just a JSON-P API. So I've got my Twitter Search API URL. I've got some placeholders in there for the query and for the callback. When I get my results back, I'm going to get this object that isn't just an object containing an array of text. It contains an array of other objects, and each object in that array represents a tweet. So if I want to complete on the tweet text, and if I want to display the text of these tweets in my AutoComplete dropdown, I've got a little bit of extra work here because I can't just tell AutoComplete use this array of objects. I have to tell it how to find the text within those objects. So I can specify a result text locator, exact same format as a list locator. This is just an object, a dot delimited string. Tells it for each result object, here's the path to the text that you want to use for completion. And so this is the text that's going to end up getting passed to highlighters. It's going to end up ultimately being displayed to the user unless you specify some custom formatting. And just like the list locator, this can be a function if you want to do some extra stuff to dig into the object and find out where it is. So you've got a lot of flexibility there. So once you've located your results, once you've got your array of results and your text within that array that you're going to use as your AutoComplete list, the next thing you're going to want to do is filter down that list potentially. So if it wasn't filtered on the server, you're going to want to filter it on the client to match the query that these are entered. And you're going to highlight those results so that the user can actually see in some form, this is the relevant part of the query that you've typed. So the prepackaged filters and highlighters that AutoComplete provides for you will probably cover most of the bases. You've got character matching, which will match individual characters. You've got phrase matching, start of string matching, and then word matching, which will match individual words within a string. And you've got these for both filtering and for highlighting, so they're equivalent. In addition to that, you've got case-sensitive versions, so you can be either case-insensitive by default, or you can specify that you want case-sensitive matching. And you can specify that you want to do accent folding. So if you want to compare based on, say the user enters the word resume, it's got some accented E's in it, or maybe the user didn't enter the accented E's, you might want to show them a result that contains the word resume and not force them to enter those accents. You can do that. And again, a few caveats there that I'll talk about in a little bit. So character matching looks like this. If my query is YUI and I'm matching this string, I'm going to match each individual character. So for both filtering and highlighting, these are the matches that are going to turn up when I use these filters. If I'm doing a phrase match, I'm looking for the complete query string in whatever result came back. So I'm not going to highlight any individual characters. I'm only going to highlight complete instances of the phrase YUI. A starts with match is just like a phrase match, but it has to match the beginning of the string. So it's not going to match that second occurrence of YUI. And then finally, a word match will take my query, and in this case, my query is only a single word. It's only going to match a complete word that matches my query. If my query has multiple words, it's going to break up my query into an array of words, and it will match any of those words in a string. So when you're filtering, you have to match all the words in order for the filter to succeed. When you're highlighting, it'll highlight any of the words in the match string. So if that's not enough for you, you can provide a custom filter, which is just a function that accepts a query as the first parameter and an array of results as the second parameter. And then you define whatever logic happens inside of this, and you return a filtered array of results. So in this case, I'm just going to be passing my result array to y.array.filter, and it's going to walk through the array, and for each item in the array, it's going to call my function, pass in the result that I'm filtering, and I can just do some arbitrary logic here. In this case, I'm doing something that's probably completely useless unless you're really interested in results that begin with the letter A. But as long as I return true, this result is going to end up in the final filtered array. If I return false, it's going to be excluded from the filtered array. And then ultimately, that array just gets returned from the filter function, and that becomes my list of autocomplete results. So using this filter function is as simple as specifying for the result filters config, here's my custom filter. You could also specify a built-in filter here in the form of a string, so I could specify string char match, string phrase match. Or I can specify an array of filters if I want to pass my results through multiple filters and whittle them down. And then what autocomplete will do is it'll pass to the first filter. Whatever comes back from that will go to the second filter, will go into the third, et cetera, until there are no more filters to run, and then that's my set of results. And you can mix and match custom filters and built-in filters if you want. So you can see I've got my custom filter, and I've got my word match filter that I'm pulling in from the prepackaged set of filters. So highlighters work essentially the same way. The only difference is instead of filtering the array of results, I'm going to change the array of results. I'm going to actually highlight something meaningful in each result. So same function signature, I get the query, I get the array of results, and then in this case, I'm going to use y.array.map to walk over each item in this array and run an arbitrary function that's going to apply some highlighting. So I'm going to use the new y.highlight module to say highlight all occurrences of the query as a phrase in this result, and then finally return an array of all of my modified highlighted results. And so just like the filter function, there's a result highlighter config. I can specify my custom highlighter here. Unlike the result filters config, you can't specify multiple highlighters. There's not really much point to that because you just end up stepping on each other's toes. So you can only highlight something once. So I've found my results, I've filtered my results, I've highlighted my results. But now maybe I want to go beyond that, and instead of just displaying some lovely highlighted text, maybe I want to display something that's more formatted. So say I'm pulling results from Twitter like we saw in that earlier example. I probably want to display those as tweets. And you're going to want to have a user profile picture, you're going to want to have like a tweet time at the bottom, maybe some other stuff in there. So the way that you do this is by specifying a custom formatter, which again is just a function. It accepts a couple of arguments. So you can see here, I get the query as the first argument again. Instead of an array of text results, now I get an array of raw results. And so this is what we saw earlier in the Twitter response. Each result is an object. So this is my array of raw results, is this array of objects. So I've got a bunch of extra data there that I can pull into my formatted results. And then in addition to the array of raw objects, I also get an array of highlighted text results. So whatever my text locator found for me and passed on to my highlighters, I get that back here. And that'll look something like this. So you've got a highlighted string with some HTML highlighting in there. So that allows me to take, and I can walk over that array of raw results, apply some logic to, all I'm doing here is I'm running a string substitution with y.lang.sub, which says take this big chunk of an HTML template. It's got some placeholders in it with curly brackets, and then take this object, and I'm going to pull in some data out of that raw result object, feed this to my replacement template, and the end result is for each result item, the array gets mapped to this HTML string, and the end result is that comes out of my formatter is an array of HTML strings for each item. And this ends up in my result list. So the result formatter is, again, it's just a config attribute. Specify your formatter function here. And you can see I've also got I've got a highlighter, and I've got a list locator there, a text locator, and my Twitter API source. I can also throw some CSS on the page if I want to make things look pretty. And then the final result is this lovely formatted Twitter autocomplete. And all I had to do was write a simple function that returns some HTML. So really easy to do and really powerful. And you can go beyond just this. You can do some pretty cool stuff without having to build your own widget around AutoComplete. So that's what AutoComplete does in the core. But in building AutoComplete, obviously there were a lot of sort of tangential things that AutoComplete needed to do in order to accomplish its goals, but that didn't really belong in the set of AutoComplete modules themselves. So in the spirit of YUI 3, we've broken these out. And so there's a bunch of new modules that you kind of get for free in YUI 3.3 because we needed them for AutoComplete. And you can use these for your own projects as well. So the first one is that event value change module that I mentioned earlier. And this actually came into the library in, I think, 3.1. And so it's been around since then. It got pretty heavily refactored in 3.2. And 3.3 is the first place where we're really actually using it as the foundation for something. So what makes this special and makes it essentially more useful than just looking for keyboard input on an input field, which you might be inclined to do, is that there's a lot of things that you're not going to be able to do just by listening for DOM events. So if you listen for keystrokes, you're potentially going to miss paste events that occur due to mouse clicks or due to someone selecting paste from a menu. But you're also likely to miss IME input, which is in languages that require multiple keystrokes to enter a single character. A lot of times you'll have an input method editor that pops up. And the DOM events like onInput, onKeyDown, they're not necessarily going to fire in all browsers for every keystroke that makes up one of these multi-keystroke characters. And sometimes you want that. You want it to fire for every keystroke because you might be able to provide relevant autocomplete results. And also you want to make sure that this event fires after the IME event has finished completely, which again, some browsers don't do very reliably when you're looking at just DOM events. So this synthetic event creates this level playing field that we can use as the foundation for capturing keyboard input into a text field. And that's what it looks like. It's really easy to use. Just attach a value change event to any input field, and then in your event subscriber, you'll get an event facade that contains the previous value of that field and whatever the new value is. So the next module is escape. So we needed a couple of ways of, obviously when a user is typing input, and then you're going to be passing that input to a highlighter and displaying it as HTML, you don't want to allow the user to type some angle brackets and scripts and alerts and steal credit card numbers and things. So we've added just a small utility module that has methods on it for escaping HTML strings, returning HTML encoded strings, and then there's another method for escaping regular expression strings. So if you've got a string that contains some dollar signs and some periods, and you want to use that in a regular expression, it'll escape that and make it safe, so it's not going to modify the behavior of the regex. And this is just a namespace. You can, in fact, we would love to see people create gallery modules that add more types of string escaping, more things beyond just HTML and regex. And of course, we're going to use this in the future too, as we have a need to add more types of escaping. So feel free to use this namespace in your own projects. That's what it looks like. Really easy to use. HTML method escapes some HTML, returns a safe version that you can use in inner HTML. Regex method escapes a regular expression and returns a version that you can use in your regex. So now I'd like to take a brief interlude in my talk and talk about something that I learned yesterday afternoon. Norbert Lindenberg, who's Yahoo's sort of internationalization expert, filed a bug against AutoComplete and pointed out something that completely surprised me, which is that the word Unicode is actually a registered trademark of the Unicode Consortium. So I can't actually use it in my API as I had been for the word breaking and the accent folding. So even though you may notice the Unicode Consortium doesn't actually follow their own guidelines for how to use their trademark, even on their trademark and logo policy page, I unfortunately have to follow their guidelines, so I can't call this thing Unicode. So throughout the rest of this talk, instead of calling it Unicode, I'm going to call it Snowman. So when you see a snowman, just assume that in 3.3 PR1, that's actually y.unicode. In later releases, we'll rename it to something that makes more sense. Late last night, I didn't trust myself to create a new API, so for now, it's just Snowman. And I apologize for the additional mental overhead that this is going to require. Hopefully, you'll get used to it. So the Snowman accent fold module provides helpers for working with accent-folded strings. And accent folding, like I said before, is where you have a string with some accents in it. You might want to do some comparisons that ignore those accents. This provides helpers for that. Again, as Norbert stressed to me yesterday, this should be a last resort because folding accents, removing accents from strings in a lot of languages, including some words in English, actually will change the meaning of that string. So you definitely don't ever want to display an accent-folded string back to the user. But it can be useful in some cases for comparison, for filtering, where you actually have a strong understanding of the types of languages that your users are using. And if you can say beyond a reasonable doubt that you can still provide relevant results and you're going to provide more relevant results by folding, this might help out. There is one other caveat with this, and that's that the Unicode standard, imagine that there was a trademark there, has a huge set of accented characters. So it's not practical for me to serve that massive data set to the client. So YUI has taken sort of a subset of that, of just alphanumeric Latin characters and numbers, some other special things in there. And so we're doing sort of this pragmatic subset that will maybe give you a rough way of comparing accent-folded strings. But if you can, you should absolutely do this on the server. You're going to have much more comprehensive data sets available to you there, and it'll be faster probably than doing it in JavaScript. And this will have an actual name before we do the final release of 3.3. So that's what it looks like, just some utility methods. You've got a method called fold that will take a string, return the folded version. You've got a method called compare, which will take two strings, compare the folded versions and tell you if they're equivalent. And then finally, you've got a helpful filter method that will take an array of strings. And just like the y.array.filter utility, it will walk through that array, pass each string in the array to a callback function. But it's going to pass it as the folded version of the string. So you can do comparisons, whatever, return true or false. And then ultimately, you'll get back. The final array will be still accented, but it'll have the results of whatever your comparisons said to do. So there's also a Snowman word break module. And this implements Snowman text segmentation guidelines for finding word breaks in strings. So this is actually really, really complex, especially if you're dealing with languages beyond just English. You can't just assume that wherever there's a space character or wherever there's some punctuation, that that's a word break, because there are tons of edge cases, not least of which is that some languages don't use spaces between words. Even in English, we have apostrophes in contractions, but we also sometimes use apostrophes to quote things. So you want to break on quotes. You don't want to break when it's a contraction. You don't want to break on thousands, separators. Lots of fun logic there. But the Snowman Consortium has created this lovely recommendation for how to implement sort of a general case word-breaking logic that tries to handle a lot of these edge cases, but it's not necessarily going to be perfect for every language. So we've implemented that. So like I said, not perfect. It's much better than a regex/b word break character class. And again, this is going to have an actual name at some point. So if you call y.snowman.wordbreak.getWords, you can pass in a string, and it'll return an array of the individual words in that string. So you can see here, it's been a little smart about not breaking apart the apostrophe, not breaking apart the thousand separator. You can also pass in, this is just one example of where we start to bump up against edge cases. If I pass in a string of Japanese, I've got some katakana characters, and I've also got some hiragana and some other characters. Word break is at least smart enough to know that you shouldn't break apart two katakana characters because those work together to form a single word. And the other glyphs are more likely to be individual words. Even though there's no spaces between them, we can probably break them apart pretty safely. Anybody know what that said, by the way? Okay. Hey. Norbert got it. I like pi. That's why he's our internationalization expert. So there's also a highlight module, and this is what performs all the highlighting behind the scenes for AutoComplete. So just some utility methods for taking a string, taking a substring, then highlighting that substring within the larger string using HTML. So you've got kind of like the filters that we saw before. You've got phrase highlighting, start of string highlighting, word highlighting. You can do accent-folded comparisons for your highlighting. So if I want to highlight the non-accented form of a substring or the accented form of a non-accented substring, I can tell the highlighter to do that comparison on the folded versions and return still the original highlighted accented version. And it's smart enough if you've got entities inside your escaped HTML, it's not going to highlight within those entities and break the output. And most importantly, I'm pretty sure nobody has a trademark on the word highlight yet, so we can actually call it highlight, which is super awesome. And that's what it looks like. So I've got a highlight.all method, and that method is essentially saying highlight all occurrences within this larger string of this substring. So that's going to do a phrase highlight, and the result that I get back is a bunch of HTML. I can say highlight only at the start, so I only get the very start of that string. Highlight individual words, but only when they're complete words. This is going to do just like the word filter did before, where if you pass in a query with multiple words, it'll break them apart and then highlight each one individually. And then for each of these, there's an accent folding version. So all fold, there's start fold, there's words fold. So if you want to do accent folded highlighting, you can optionally use these methods. But again, I would stress the importance of understanding when to use accent folding and when not to use accent folding. And I don't know if Norbert's actually going to address this in his talk tomorrow on internationalization, but probably definitely a talk that you would want to attend just to get some insight into how YUI allows you to define different subsets of modules for users using different languages, and in general some of the problems that you might encounter there. So yeah, here's my highlighted accent folded string. So looking at that slide, you may have asked yourself, why is he using the B element to highlight these strings? I thought B was deprecated. I thought HTML5 said, only use it as a last resort. Well, HTML5 actually defines a new element called mark that it recommends that you use for this purpose. And HTML5 says that mark is to be used for denoting the relevance of a span of text as opposed to the importance. So if I've got a situation where I'm quoting some text, which is ultimately what we're doing in AutoComplete, we're completing something that's really coming from a different source. And I want to say this part of whatever I'm quoting is relevant to whatever you did here in your query, but it's not necessarily important in the context of the original thing. It's not going to be emphasized wherever it came from. That's when I would use mark. So unfortunately, we can't use mark because it doesn't work in all browsers. You may have heard of a browser that I won't name, but it starts with the letter I and ends with the letter E. We would have to do some extra work to insert an HTML shim to support this element. So instead of doing that and forcing everybody who uses YUI highlight to use this HTML shim and to use HTML5, we use B, which HTML5 says can be used as a last resort for this type of thing. So B essentially says this thing is relevant. Don't emphasize it, but it's a little bit different from the text that's around it. But it has no real semantic impact on the original text, whatever the source of that text was. And if you don't like this, if you would rather use the mark element, if you're comfortable using HTML5 on your site, you can customize the markup template that highlight uses just by changing this value here. So we're racing towards the finish. I want to recap what I just told you. So to recap, modular architecture, awesome. Dead simple JSONP and YQL. Drop autocomplete in a page, throw in a YQL query. You can even do some awesome stuff on YQL with custom tables. Have a blast there. Prepackaged filters and highlighters. Word breaking, accent folding, snowman. Custom result formatters is super easy to do. Totally optional, so you can use the boring text results if you want. But if you want to do something more fancy, just provide a function. And finally, all of this is in YUI 3.3 PR1, including our trademark violation. So don't start using that Unicode stuff too heavily yet. You'll have to change it. But everything else, please start using it. Send feedback, file bugs, and let me know what's missing, what you'd like to see in future versions. So there is one more extra little thing, sort of a little hobby project that I did in a bit of a rush after finishing the rest of the autocomplete stuff. And that's this thing here, which is called node token input. So this is a really great little plugin for an input node that allows you to say, I've got this node, people are going to type some stuff into it. It's going to be for tokenized input, so maybe it's a tagging field that's going to have commas or spaces between tags. Maybe it's for entering email addresses, and you want to give them a really nice display of the stuff that they've entered in the form of tokens. This can help you do that. So this is in the gallery now. You can just include the gallery node token input module, grab a reference to an input field, plug in the node token input plugin. Optionally, you could also plug in AutoComplete, like you saw in that demo, to get token input plus AutoComplete. And now you've got this lovely token input control that looks very much like the NS token field that you may have seen in Cocoa apps, and can hopefully provide a really awesome interaction pattern for your users. There are a few rough edges. Like I said, I was kind of in a hurry when I implemented this. I still think it's really awesome. The pattern itself is tricky to implement in browsers because you can't actually modify the display of a real input field. So there's a little bit of hackery to create something that works a lot like an input field and then use some carefully positioned input fields to accept input. So if you run into bugs, please file those. But definitely try it out. I think it's a really cool interaction that can be super useful. And that's the end of my talk. Thank you all for coming. And